What's up everyone? Welcome back to Just Finish Coding. In this Python tutorial, we're going to be finding a remainder without using the modulus operator. Let's get coding.
Just finished coding.
Now, the question we are faced with is to write a program that that accepts a dividend and a divisor and prints out the remainder, but we are instructed not to use the modulus operator. So as usual, let's go step by step. So first, let's accept the dividend. So I'm going to say print enter dividend, and I'm going to be setting the dividend to be a dt. Okay, so dt is equals to the int of the input, and this basically converts the input, which is a string, into an integer where we can perform operations. And then I'm going to set di to be the divisor, and again we forgot to print out that, so I'm going to print enter divisor, and di is going to be equals to the int of the input. Okay, there we are. Now we have the dividend and the divisor. Now a really easy way to get the remainder is to use the modulus operator, and we can do that by just saying, let's actually print those two out first. So print the remainder when space, and then we concatenate the string of dividend is divided by, I didn't put a string right there, you want to make sure you have a string. Yeah, there we are. Sorry for this really annoying text that keeps appearing up there. Sorry about that. So dividend is divided by, and then concatenate the string of di, okay, is concatenate that as well, and here we are. So is, and we'll store the remainder in the variable r, so concatenate string r to that. Cool. So now what we need to do is to find the remainder, and that's pretty simple. We can just say r is equals to dd mod, and mod is the percentage sign di, and this works. Okay, so let me just show you what I mean. So enter the dividend, I'm going to say 12, divisor is 5, and we get the remainder is 2. So perfect, this would perform what we need to do. But it specifically instructed us not to use the modulus operator. And this may sound kind of unnecessary because, I mean, if we have just a one line of code, why should we not use that simple bit of the operator, right? But this thing I feel is done for a good reason, because it really gives you an intuitive idea of how the modulus operator actually works. So let's actually find the remainder now. So I'm gonna hit the enter key a couple of times so that I have some space. Now here's what we need to do. First, initialize a variable called c. Okay, I'm going to set c to be equals to 1. Okay, and now basically we're going to have c is basically going to be what the divisor is going to be multiplied by, and it's going to be changing constantly. You'll get what I mean in a second. So di times c, okay, would give us the value, and we have plus the remainder in order to give us the quotient, I keep messing up, the dividend in the end. Okay, so c, you can kind of view it as the quotient, but we're consistently going to change c in order to find that. Actually, let me call it q. Okay, that makes probably a little more sense here. Okay, Cool. Now we have the quotient. So what we need to do is to keep repeating this, okay? These this, and we want to increment q every single time, okay? And from this, we're gonna from the dividend we're gonna subtract this, and then check if that the result that we get from that subtraction is actually more than the divisor. If it is more than the divisor, then we can obviously increment q, because it would we could basically never have a remainder that is greater than the divisor. I hope you get what I mean here. So in order to do that, let's first initialize q equals to 1. And now I'm going to have a while, okay? And we're going to be storing our answer inside that value, okay? So value is going to be or I'm going to set it as irem, okay? So this is basically going to hold the temporary remainder, you could say. So initially, I'm going to set irem to, I don't know, let's set it to, it just should not be the divisor. So I'm going to set irem to di plus 1, okay? We just need to make sure it's more than the divisor in order for this loop to actually even go through. So now, while divisor is less than irem, here's what we need to do. So first we have di times q, okay, which is going to be our, or you could say quotient times the divisor, and we are going to subtract this from dd, okay? So this is going to give us our temporary irem value. So in case irem is, I think I hit div instead of di, okay, I meant di right there. So here we are going to get a pretty neat, I forgot an equals to, we're going to get irem, which is the temporary remainder, as the remainder here. And now we're going to increment q after this. We have a pretty neat, we have some pretty neat blocks of code here, okay? So q is going to increment every single time. And before I actually start commenting on this, I want to test this to make sure it's perfect. So enter the dividend, I'm going to say 10, and divisor is 3. And ooh, we seem to have some really weird errors, okay? And that's because our name r is not defined, and that's because we kind of stored it as irem, okay? So here we are. So run, dividend is 10, divisor is 3, and boom, we've got 1. Perfect, so our program works. Now let me explain this to you. So initially we're going to have the temporary remainder to be greater than the divisor so that we enter this loop, okay? And now we're going to be setting the temporary remainder to this the dividend minus the divisor times the quotient, which would generally give us the remainder. But here you have to remember our quotient changes every single time we pass through this loop and come back in, okay? So first we're going to have di times 1, then we're going to have di times 2, then di times 3, etc. Okay. So a small thing to note here, we actually have a small bug in this program, and we could fix that by just setting q to be equals to 0. But I'm going to show you what the bug actually is. Okay. So enter the dividend. I'm going to enter it as less than the divisor, and I want you to see what happens. So this is -2, which is, no, that should not be the case, right? So what we need is to have the q as 0, and then we will be having dividend is 3, divisor is 1, and wait, 3 divided by 1. Okay, again, we have another bug right there. But this is not what we wanted to do. So we have dividend is 1, divisor is 3, and boom, we have a remainder when 1 is divided by 3 is 1, because our quotient is going to be 0. Perfect. Now let's actually try that bug which we seem to get. So dividend is 3, divisor is 1, and remainder when 3 is divided by 1 is 1. Ooh, seems to be like something is wrong here. So let's work it out step by step now. So our quotient initially is going to be equals to 0. Our remainder is going to be set to the divisor plus 1, which is 2. So while uh, 1 is less than 2, okay, we're going to be setting this to dd minus di times q is 0, so uh, to the dividend itself, and then now we're going to increment q, okay, because now 0 is not. So yeah, so our temporary remainder would be the dividend itself, which is 3. So 3 minus 0, that's 3. And now this is again, di is less than 3, so it's going to go back in. Now the dividend, which is 3 minus 1 times 1, okay, that's going to, I think the reason our thing is a bit incorrect is because it won't get perfect. What do I say? Where the remainder is 0, that's where our thing seems to be going wrong. So this should fix that. So enter the dividend 12, 4, and 0. Yeah, perfect. That's it. So it was basically stopping because it was greater than, not incrementing one more time. So that's it we need to do, and our program works exactly the way we want it to. So you could do a bit of additional debugging if you want to here, and you would check out my previous videos. I'm not going to be doing it right now because I mean in this case it really doesn't matter, okay? But in some cases, especially games and if you're building apps and stuff like that, you want to make sure the user can't crash your program by just trying to tamper with it in some way of his own, okay? So in that case, you'd want debugging, but here I don't think it's really required. So with that said, thanks everyone for watching. Make sure you hit that like button because it really boosts my rating on the YouTube algorithm, and it's basically 2 seconds of your time, guys. So please hit the like button. Also hit the subscribe button and the notification bell so that you're notified on every single upload of ours, which is daily. We have a daily upload frequency, and we're going to be uploading new videos like this every single day. So with that said, thanks everyone for watching. I'll see you tomorrow. Bye bye.